Hello friends, I'm back with the fourth module of my series on ESG and its importance for dairy industry. There has been a considerable gap since I last uploaded my module as I was preoccupied in certain unavoidable personal and official tasks. I'm deeply sorry for the same. Friends, in the first module, we gave an introduction to the concept of environment, social and governance. For the ease of understanding, the whole concept has been broken down into five major areas, namely animals, farmers, processing and transportation, sales and distribution, and consumers, based on their implication on ESG. In the second module, we touched upon all the five areas and provided a brief introduction of each area. The third module dealt with the first two areas, that is, animals and farmers, in detail. Now, in the present module, we will be covering the third area, which is a very important area of raw milk transportation and milk processing, and its impact on environment, social, and governance, and ways to mitigate the adverse impacts. Hope you will like the presentation as much as you have done in the earlier modules. Please do not forget to like the video and also subscribe to my channel so that you continue to get updates about my future offerings. Happy viewing. As mentioned earlier, adoption of environment friendly and socially responsible practices, the two important and critical components of ESG, becomes beneficial for the dairy industry for its long-term sustenance and financial viability. Based on the above, the whole gamut of ESG in dairy industry can be classified into five categories: animals, farmers, milk handling post milking, that is raw material transportation and processing, consumers, and sales and distribution. While the third module discussed the areas of animals and farmers, in this module we will talk about raw material transportation and processing and its impact on environment and society. Raw material transportation has an impact on environment through GHG emissions and can be taken care of by optimizing the route lengths and use of alternative green fuels. The milk processing, on the other hand, impacts through the usage of water, effluent treatment, power usage, packaging materials, and process automations. In subsequent slides, we will talk about each component in detail. Transportation has a significant impact within the food and beverage sector because food is often shipped long distances, as the production centers, largely the villages or rural areas, and the consumption centers, cities and smaller towns, urban centers, are situated far apart. Although the impact of transportation is important, full life cycle analysis indicates that for most food transportation does not have the large environmental impact. Following slides talk about the impact of transportation of food and especially milk from village level production areas up to the processing plants. The second leg of transportation from plant to market will be discussed in subsequent module where we will discuss the sales and distribution. Transportation of milk from villages to BMC, MCC and from MCC to plant involves usage of fossil fuels, resulting in GHG emissions. However, the impact of transportation of milk as a food item on environment is not very high. A comprehensive study carried out across 119 countries at over 38,500 farms indicates that the GHG emissions on account of milk is hardly 1/20th of that due to beef from beef herd, about 3 kg carbon dioxide equivalent per kg of milk versus 60 kg per kg in case of beef. Moreover, out of these 3 kg per kg of milk, hardly 4 to 5% of total emissions is generated by transportation of milk. Major part of the total emissions is contributed by land use changes, that is 18%, and farm practices. So in case the objective is to cut down GHG emissions due to milk, major effort need to be focused on farm practices for animal husbandry and fodder production. Still, it is in the interest of the organization and economy to optimize the transportation effect on environment for cost control, transportation optimization, saving time and maintaining raw material quality, and due to global focus on fossil fuel non-proliferation, making use of petroleum products non-sustainable in coming future. Most of the organizations have now started making concerted efforts to switch over to more sustainable and environment friendly alternatives like electricity, CNG, etc. to power the vehicular transportation for milk. The regulatory push from concerned governments has also played a major role in this regard. This slide gives details about GHG emissions by various food items. Water is an important utility for dairy plants as it governs the hygiene of plants. In the past, abundant and inexpensive sources of water were taken for granted in the dairy processing industry, and not much thought was given to economize its use. But in recent times, we have witnessed acute water scarcity and drought conditions in various parts of the country. Besides, indiscriminate use of water also results in excessive wastewater generation, which becomes a burden for the industry in terms of treatment and disposal cost. Dairy processors, therefore, are aggressively challenged to conserve water, necessitating the need for not only reducing water consumption but also to employ measures for recovery and recycling of processed water without compromising on the hygienic quality and safety of the products. Subsequent slides will talk about various uses of water in a dairy plant, areas of water losses, what wastewater control measures, and water reuse as part of making dairy operations sustainable. Various types of uses in a dairy plant are processed water, water used for direct preparation of products, cleaning purposes, and various technical purposes, cooling water, water used for removal of heat from processed streams and products, boiler feed water, water required for steam generation, and miscellaneous ancillary purposes like amenities and gardens, and extraordinary incidents like fire protection, etc. Depending upon the product mix, dairy processing plants can use substantial volumes of water for cleaning, cooling towers, boilers, and other processes. Generally, the water consumption of dairy plants ranges between 1 to 2.5 liters per liter of milk. However, a number of organizations have been able to achieve close to 1 liter per liter of milk using innovative practices and techniques. Now let us look at various areas of water losses. Losses in RMRD, manual cleaning of cans with running water hoses due to water lubricating of conveyors. In process sections, operating pasteurizer for short duration, draining of condensate from pasteurizer, water overflowing from balance tank when pasteurizer and other equipment are on the rinse, manual cleaning of separator with running water hoses, cleaning of milk tanks by high pressure discharge points. In milk filling section, manual cleaning of crates with running water hoses, and machine cooling water drained. Areas of water losses in butter and ghee section. Draining of cooling water sprayed over butter chunks. Draining of condensate from ghee boiler. Draining of cooling water from settling tanks. In evaporating and drying sections. Draining of condensate from evaporator. Operating evaporator for short duration and frequent cleaning. In CIP section. CIP done without recirculation or used CIP solution being drained frequently. CIP system not recovering final rinsed water for reuse as pre-rinsed water. Erase water loss in refrigeration section. Draining chilled water or leakage in chilled water system. Evaporation losses in atmospheric condensers. Other general areas. Inadvertent use of water at wash points. Frequent and excessive floor cleaning by high pressure discharge points. Draining of pump seal water. Now let us see why we need to economize water usage. Major reasons necessitating water conservation in dairy are increasing water cost, water availability becoming critical everywhere, regulations becoming more stringent, and increased water cost of wastewater treatment and its disposal, because indiscriminate use generate excessive wastewater. Now, what are various wastewater control measures? In dairy production, there are various possibilities for increasing water use efficiency and promoting water reuse. Dairy's water conservation agenda could be based on the following. Think of water as a raw material with a cost. Make water conservation a management priority. Set specific water conservation goals for your plant. Reuse water wherever possible. Train employees how to use water efficiently. And establish a recognition and reward program for employees and teams who do an outstanding job. To implement an effective water control measure, it is essential that adequate water metering facilities are installed at the dairy plant. This should include a meter at each of the points of entry of water into the dairy plant and meters on the supply to individual departments or equipment with major usage of water. Money invested in such meters is very useful. Some specific ways of decreasing water use in dairy industry may be enumerated as below. Review cleaning process and adopt dry cleaning wherever possible. Use high pressure, low volume cleaners for cleaning surfaces. Use automatic shut-off nozzles on all water hoses. Pre-soak floors and equipment to loosen dirt before final cleaning. Prevent spills of ingredients and raw milk and products. Clean up spills before washing. Reuse CIP solutions appropriately. And reuse final rinse water as pre-rinse for next CIP cycle. Further, prevent pasteurizers circulating on water as this results in water wastage due to overflow. Recirculate homogenizer and pump sealing water. Use continuous rather than batch processing to reduce frequency of cleaning. Collect condensate for reuse. Maintain cooling towers in proper working condition and regularly remove scales. Prevent excess water loss from drift in cooling towers. Install water meters wherever possible and read them regularly. And prevent all water and steam leakages. Water reuse is another way of improving the water efficiency. Besides preventing water loss, another way of optimizing water usage could be reuse of water. This not only helps in reducing demand for fresh water, but also cuts down wastewater generation, treatment, and disposal of which is expensive and cumbersome. Water that is considered suitable for reuse is the one which is recovered from a processing step that can be reused in the same prior or post food processing operation after reconditioning treatment. Reusable water can be of three types: recirculated water, reclaimed water, and recycled water. In subsequent slides, we'll talk about these three types. Now, what is hygienic reuse of processed water? Reused water should be safe for its intended use and shall not jeopardize the product safety through introduction of chemicals, microbiological or physical contaminants. Such water shall at least meet the microbiological and, as deemed necessary, chemical specifications for potable water. It should not adversely affect the quality and sustainability of the product. It should be subject to ongoing monitoring and testing to ensure safety and quality. Unless reconditioned to potable water quality, distribution of reused water should be in clearly marked, for example, different colors, systems, including piping and outlets that are separate from the distribution lines for potable water. Cross contamination by backflow, back siphonage, or cross connections from reused water should be prevented. Storage vessels should be properly constructed of materials that will not contaminate the water and should be periodically cleaned and sanitized. Proper maintenance of water reconditioning system is critical to avoid having the system become source of contamination, and water that is recycled or reused will need to be treated to improve its quality, particularly when it comes into contact with food or is used to clean surfaces that will come in contact with the products. Advanced water treatment technologies make it possible to treat water to very high degree, significantly reducing potential health risks associated with water reuse. It is even possible to treat wastewater to such a high degree that it can be safely used as a supplement to potable drinking water supplies. However, treating water to a high degree is expensive. The quality of water and the degree of treatment required should correspond to the intended water use. Reconditioning or treatment of water for reuse should be undertaken with the knowledge of the types of contaminants the water may have acquired from its previous use. Extremely large volumes of reused water may justify the use of one or a combination of advanced wastewater treatment systems like filtration, denitrification, phosphorus removal, coagulation sedimentation, and disinfection, and requires analysis of critical control points and an evaluation of the potential for contamination of the food product. Dairy industry is one of the most polluting food industry in terms of large amount of water used during production of milk and milk products. The wastewater contains dissolved sugars, proteins, and fat, which is organic in nature and biodegradable. Dairy wastewater is considered to have high concentration of organic matter and high BOD. It is estimated that dairy industry generates 1.5 to 3 liters of wastewater per liter of milk processed. Poorly treated wastewater with high degree of pollutants resulting from poor design, operation and treatment system creates major environmental problems. Such untreated wastewater pollutes land and river system so that proper treatment of dairy wastewater becomes necessary before disposal in environment. Apart from meeting the regulatory requirement with respect to effluent treatment, it is also a social responsibility of the organization to ensure that the wastewater generated at the dairy plant is properly treated before it is disposed of. Subsequent slides will talk about ETP in detail. Now let us look at effluent treatment. Wastewater effluent is simply diluted milk and highly biodegradable. The dairy effluent generally has dilutions of milk products from washing of flour, milk spillage, liquid effluent of cheese, paneer, yogurt production called whey. This is a concoction of salts, minerals, detergents, sanitizers, caustic soda, citric acid from the CIP process, washing from the trucks, cans, tankers, storage tanks, etc. It is highly organic in nature, having high chemical oxygen demand, that is COD, and if untreated effluent is let out in the natural water bodies, it causes a lot of adverse impacts like if discharged in inland surface water, it may cause depletion of dissolved oxygen, distress to fish due to toxicity, radioactive concentration, especially on pastures. If discharged on land, it may cause anaerobic conditions, especially in heavy soils, to develop foul odor and ponding. Discharge in public sewers may turn sewer water septic in sewer only, necessitating pre-treatment for aeration in sewage plant due to presence of carbohydrates and high temperature of discharge. Due to the above, it becomes incumbent upon the dairy organizations to properly treat the effluent because before it is safely disposed of. This not only is a regulatory requirement but also a social obligation on the part of the organization so as to ensure that the operations are socially responsible. Effluent treatment and disposal is a specialized task and needs expert advice and support. Most of the responsible organizations seek help from specialist service providers in setting up an effective and efficient effluent treatment plant, that is ETP, and set up a special in-house team for its proper running and upkeep. The dairy processing industry spends huge amount on purchase of fuels and electricity, making energy a substantial cost driver for the industry. Energy efficiency enhancement is an important way to reduce these costs and to increase predictable earnings in the face of ongoing energy price volatility. The concern towards environment and increasing price of fuels has raised the alarm towards energy efficient measures. A dedicated and planned energy management program will help to detect and counterbalance energy efficiency measures and practices across the organization and ensure unremitting improvements. Use of conventional energy is common practice for major processing of milk. Most of the milk processing operations, room air conditioning for milk and milk product packaging, and cold stores for milk and milk product operate on grid electricity supply with diesel genset as a backup. Apart from the huge cost implication, this also has a substantial environmental impact as the generation of electricity involves usage of fossil fuels like coal, lignite, gas and diesel accounting for 58% of total electricity generation apart from hydro 11%, renewable sources 30% and nuclear power 1%. Over the past few years, there has been a major focus of the international community to bring down the use of fossil fuels so as to mitigate its adverse impact on environment and contain global warming. It is therefore in the fitness of things that the dairy industry, a big user of electricity, contributes its efforts in this direction. Like water management, this is also a specialized task and would need expert advice. There are various organizations whose support may be taken to design and implement an effective energy optimization program. This can be done in two ways. Optimization of electricity usage. Very often, the electrical energy is wasted due to the negligence of and lack of awareness in the workforce. Other times, more energy is used than required due to low power factor, use of substandard equipment, use of low energy efficiency equipment, and such other factors. An efficient energy management program would include an energy audit as its essential first step. The energy audit would bring out the usage of electricity as the ratio of milk throughput to each unit of electricity used, and the effort should be made to continually improve it. Ideally, the audit should be carried out on a regular basis rather than doing it as a one-time exercise. An efficient electrical energy conservation program should consider the following: power factor management, use of standard equipment, using energy efficient equipment and or systems, using controllers and timers, efficient lighting management. A detailed and planned energy management program will help to detect and implement energy efficiency measures and practices across the organization and ensure continuous improvement. Second is using alternate sources of energy. Conventionally, electricity generation in India is largely done using fossil fuels, which is now under close scrutiny due to its adverse impact on environment. Various alternative sources are now in focus: hydropower, solar energy, wind power, and nuclear power. While nuclear power is still in a nascent stage in India, hydropower is limited by high capital cost and complexity of transmission of power from generation to consumption centers. Renewable sources like solar and wind are gaining popularity primarily due to the fact that these are considered to be clean and green, and also because of the ease of installation and distribution. Investment in solar energy technology is being encouraged as the merits include pollution free environment, free and renewable energy source, high reliability, and low maintenance cost. GOI, as part of their commitment to achieve net zero emissions by 2070 and phase out fossil fuels, has been encouraging alternative sources of energy, mainly solar and wind. As per a report by the International Energy Agency (IEA) in India, variable renewables have the lowest expected levelized generation cost. Utility scale solar PV and onshore wind are the least cost options. Except for the coastal areas, solar energy is the most popular non-conventional source of energy and is easy and convenient to install as it requires much less space as compared to other methods including windmills. During the past 8 to 10 years, the solar energy has gained a lot of traction and popularity across various industries with financial and policy level support from the government. Use of solar energy has great scope for its commercial use in the dairy processing operations like solar energy for cooling purpose, solar based refrigeration plant, solar water heating, solar heating for steam generation in dairy, solar drying in dairy operations, solar energy for pumping dairy fluids, solar energy to lighten dairy offices and premises, and solar energy for electrification, that is electric fences. Packaging plays a crucial role in the dairy industry, from production to consumption, and supports resilient and sustainable food supply chains. The dairy industry chooses packing materials based on several factors, such as product type, processing and storage conditions, requirements for handling, and the end use. The packaging material must be inert and should not interact with the packed dairy product. But current trends are towards the development of packaging that includes certain interactions to extend the shelf life. The dairy industry uses glass and or plastic bottles, laminates, multi-layer materials, pouches, plastic tubs, cans, and other containers. There is no good or bad packaging material as such, or a one size fits all approach. It all depends on the balance between the necessary packaging function and the minimum effect on the environment. The dairy industry can play a significant part in promoting sustainability by using packaging that is biodegradable, compostable, recyclable, and reusable. Biodegradable packaging made from renewable materials like cornstarch, sugarcane, or plant based polymers is one of the most promising remedies. Compostable packaging is another sustainable choice for the dairy industry, and recyclable packaging, refillable and reusable containers, and innovative materials are other sustainable packaging solutions. While the major push for adopting sustainable and environment friendly packaging is coming from the regulatory authorities, a number of consumer driven trends are also forcing the manufacturers to look for alternatives. World over, the consumers are selecting brands that more closely reflect their values in relation to environmental stewardship. Sustainable packaging should be able to claim recyclability in current eco streams as well as establish that the packaging is made out of post-consumer recycled content. In the future, more and more manufacturers will rely on renewable raw materials like paper and will reduce the most predominantly used packaging material, that is plastic. Some examples of more sustainable packaging can be plastic snap-on lids for yogurts and curd cup being replaced by reusable lids or peel-off lids with integrated drinking openings, or paper or PP monomaterials replacing plastic as major packaging material. Although paper has a better ecological footprint, it is more sensitive as it tears or creases more quickly, and thus product handling in the machine and during transport is more challenging and needs more research. Monoseal film, a recent development, claims lower sealing temperature and faster sealing time, thus allowing use of longer film rolls with less changeover time and less film over time. It is claimed that this can work on existing form, fill and seal equipment without major changeover or retrofit, saving capital expenditure. Flexible packaging, replacing rigid packaging, may also be the step in right direction, as it takes less energy to produce squeezable packaging than it does for a rigid container. It is also easier and more economical to transport flexible empties rather than rigid packing, thus saving on cost as well as causing lesser emissions during transport. Tetra Classic aseptic cube for dairy, juices and liquid food items is shaped in such a manner that 6 such packs form a cube, thus saving transportation space significantly and making it cost effective as well as environmentally sustainable. Containers made of bioplastic containing lactic acid from vegetable sugar and starch are claimed to be free from synthetic plasticides, extremely lighter than glass, and completely biodegradable. These alternative materials also need to be tested for necessary machine adjustments and sensory effects on the products to support customers in their transition to sustainable materials. Automated manufacturing is inherently sustainable. Its existence allows companies to create and use that minimize the negative environmental impact. This helps companies to achieve manufacturing goals, including lowered energy, water, and land usage. Manufacturing automation, often referred to as factory automation or industrial automation, uses a combination of software, computers, and robotics or control systems in place of human labor. Smart manufacturing connects various control systems through the Internet of Things (IoT). Using a combination of data analytics and machine learning, these devices work together to create a more efficient and sustainable process. Automated manufacturing is inherently sustainable as it allows companies to minimize the negative environmental impact by helping companies to achieve manufacturing goals, including lowered energy, water, and land use. Automation can potentially improve several aspects of dairy processing. However, this potential can be fully exploited only if there is a well thought out and custom designed process which implies the correct use of the available technology once running. Some ways that automation helps in creating sustainable operation are: data collected is used to ensure the machines are efficient. More efficient machines have lower heating requirements. Reduced cycle times resulting in reduced energy to output ratio. Robots help to streamline processes, meaning less material waste. Robots can be compact and can streamline processes, thus requiring less factory floor space. Investing in sustainable innovation also pays by making the operations economically competitive in long run. Although it may not be feasible to completely automate the dairy processing system, whenever specific approach, premises dimension, and the volume of operation warrants, it makes sense to automate the process. Through automation, the main benefit which can be derived is the process optimization that leads to cost savings on one hand and improving the environmental performance of the plant on the other. Operation becomes more sustainable by helping in early identification of bottlenecks that limit the efficiency, reduce energy losses, and process losses and wastage. Automation allows us to enhance production volumes, improve productivity, better input-output ratios, and establish specific quality parameters permitting to maintain individual quality standards for the products as per the norms. Use of sensors in an automated operation ensures that potential physical contaminants are not allowed to enter the product, and thus the detrimental effect of product recall and food safety are effectively addressed. The latest developments in dairy automation have also helped on food traceability front through the information gathered and analyzed on real-time basis to throw up relevant data. The automation of plant operations is expected to have a significant impact on the workforce. As machine takes over many of the tasks that were once performed by humans, the nature of work will change and many employees will need to develop new skills. To prepare for the future of work, it becomes the responsibility of the organization to focus on upskilling and reskilling their employees. This will also help the organizations unleashing the full potential of operational automation. Upskilling involves developing new skills to help employees in their current roles. Reskilling would mean acquiring the capabilities to take on different or entirely new roles. As per a report by McKinsey, nearly every job will change, many quite profoundly, and the overwhelming majority of today's employees will need to develop new skills. The report suggests that the future of work will require two types of changes across the workforce: upskilling, in which staff gain new skills to help in their current roles, and reskilling, in which staff need to the capabilities to take on different or entirely new roles. The reskilling challenges will be particularly acute in operationally intensive sectors such as manufacturing, transportation, and operations aligned occupations such as maintenance, claim processing, and warehouse order picking. The report also suggests that 39 to 58% of the worldwide workforce activities in operationally intensive sectors could be automated using currently demonstrated technologies. So friends, with this we come to the end of module 4 of my series on ESG and its importance for dairy industry. Hope I have been able to convey what I had set out in the beginning. In case you like the video, please do not forget to like it, and if you have not subscribed to my channel so far, please do so as to keep getting notifications about my future offerings on the subject. At the end of this slide, I've also shared links to the first 3 modules in this series for your convenience, so that if you have missed my earlier videos or want to refresh, you may do so by clicking on the relevant links. Very soon, I will come up with the next module. Until then, goodbye.